So the conversation, I would welcome the panel to make its way up on stage. The panel is going to be moderated by NSET member Treye Thomas from the Consumer Product Safety Commission and includes Doyle Edwards, Director of Government Programs for Brewer Science, Reg Rogers, who's Associate Professor in the Department of Chemical and Biomedical Engineering at the University of Missouri, and Jamie Wetmore, who's an associate professor in the School for the Future of Innovation in Society at Arizona State University. So take it away.
Okay. Good morning. I'm not looking too happy on that picture, but I am really happy to be here. I guess that's what 20 years will do to you in the NNI. No, it has been an incredible experience to work over these 20 years in a subgroup of, as Brandon talked about, the nano EHS. There's been a tremendous amount of work done, a tremendous community of research and practice that has been created over these years. And so we're really excited with this panel to talk more about the perspectives on what we've done over the past 20 years. So without further ado, we only have a few minutes and there's a lot to talk about. And for those online, you can submit questions. So I'm going to start with the first question, which talks about the acceptance of nanotechnology. So in the early days of nanotechnology in the United States, it's characterized by concerns around its safety and possible applications. Addressing these worries has been a major aspect of the responsible development goals of the NNI. So the first question to our panelists is, where do you think we are now in terms of acceptance and adoption of nanotechnology generally?
So yeah, there were a lot of concerns early days. One of my favorite research studies I ever saw was a student who chronicled the use of nano in comic books. And nano for a while was the source of powers for amazing new superheroes. And then over the course of 1 year, nano became the evil thing that the villain was going to use to destroy the world. And then it changed like that. But I think in popular culture, it's really interesting that we haven't had a big nano, there hasn't been a terrifying media blitz about nano in the last 20 years. And I think that's gone a long way, maybe not necessarily to public acceptance, but public complacency and not worrying so much about it. The other player involved in this, which I think has been really important, was an organization funded by the NSF called the Nanoscale Informal Science Education Network. And if you ever did nano days or got those boxes delivered to your lab to introduce the public to the idea of nanotechnology, that project reached more people than almost any other any other science education program ever created. They ended up creating kits which were reaching 10 million people a year. So that kind of action, I think, played a huge, huge role in at least educating the public a little bit to understand what was going on.
Yeah, I remember just talking to my parents, especially when I started getting into the field and working with it, and my mom like vehemently was like, absolutely not. I will not be working with that. I do not want that on my body. I don't want this in my clothes. I don't want any of that. So you could tell there was a kind of a generation stigma there of what is going to happen with nanomaterials if my own parents are refusing to accept it. But, it just took time. And I think that was one of the things I noticed. That it took time for my mother especially to recognize that, oh, this isn't that bad. All right, this is something that we can work with. And I think as we continue to go along here, we're seeing more and more acceptance because people are recognizing that there's a benefit. And it comes back to the cost-benefit relationship here. Hey, there's a benefit to working with nanomaterials, and it's just a matter of getting people to understand the scale of it. And as long as people recognize that, hey, there's a direction with it and where we can actually make this something useful for our everyday lives, people will take that time to understand, hey, how do I apply it to my own lifestyle?
So I'm going to jump right into our engagement with the NNI about 10, 15 years ago. And we were developing some products using carbon nanotubes. And it's kind of interesting seeing Richard Smalley's name up here and some of the work we were doing there. And at that point in time, there was a lot of fear. uh, about the use of carbon nanotubes in different products, and we were developing we're in the semiconductor industry and developing a nano memory. But through this community, we understood and learned some of the benefits of not only the nanotechnology, but how to utilize it and what are some of the fears, but also how do we overcome some of those fears. So engaging through this community, we met people like Chuck Treye and NIOSH and developed some good practices of handling them. Then we connected to other people, the Army Corps of Engineers, environmental labs, and developing some different protocols based around that. Worked with Alan Kennedy and Jeff Stevens, and then connect later to the people like Matt Hall with NanoSafe. And so through that, we now have developed a series and a line of sensors, environmental sensors based on nanotechnology. So the fear moved away from fear to acceptance to understanding to now we have some products that we're taking to market.
Great, thank you. This is somewhat of a provocative question, given what we've heard this morning about really the great research and challenges that we've met in nanotechnology. We do want to ask you what you think about where we are in terms of acceptance and adoption, but also, can you talk about, we've had a new group of scientists that have been created, so to speak, that have been, their research has been engaged in nanoscience in their doctoral and postdoctoral efforts. Can you talk about the new generation of scientists and what they may think versus those that have been in nano for several years? Before we start.
So a big part of my project, I started with the Center for Nanotechnology and Society, and one of our big goals was to bring social scientists, humanists, scientists, and engineers together to actively work with each other, learn from each other. And one of the big programs I've been involved for a long time is sort of training programs for scientists and engineers to help them understand the big picture of their work, the ethical implications of their work, the way their work may or may not change the entire world for better or for worse. And in the early days of doing this, sort of 2007, 2008, we had lots of excited students and faculty members who were a little nervous whenever we got in the room. I remember one student trying to come to a class that I taught was told by their advisor they had to turn around or they would have to leave their PhD program. The world is different now, and those students that I engaged with are more powerful than they've ever been before. They are interested in social justice. They are interested in making sure their work does good things for the world. And I'm incredibly, incredibly heartened to see sort of the evolution of scientists and engineers in this country more and more interested in making sure that their work has a positive impact and finding ways to figure out how to do that. Then I think that's a fundamental difference, recognizing the big picture and trying to engage with it.
Yeah, so Jamie pretty much answered most of what I was going to say, but I'll put it to you this way. When you have students at the door, banging at the door going, I want to get involved in research, and you first sit there and say, why? And they go, I like nano. I like the idea of nano and what it can do, especially for environmental reasons. And being able to see that this generation that we have right now, they're entrepreneurs. I'll just put it to you that way. They're very much entrepreneurial. They want to be creative in what they get involved in. They understand implications, you know, whether it be a societal impact implication or whether it be a more technical implication. They have that already in the grain. They have the nucleus, so to speak, and they just need more of that nurturing to help them develop it further. And so I think in terms of acceptance of the current generation versus where we were before, the students I see today are gung-ho, all right? They want to get involved. There's no holding them back. They will find a way to get engaged with it. And it's a matter of, are we providing them the opportunity? And if we're not, what do we need to do to provide them more opportunities to be unleashed with their entrepreneurial aspects?
So this is the fun part, because we work with both Arizona State and University of Missouri, and we could benefit from this. So we get to hire these students, and they come in already excited, already engaged, already thinking of big, grand ideas based around nano. And then we get to turn those into, okay, what ifs, and get to try these out in new products and new directions. So it's what a neat ecosystem to be able to tap into.
All right. Now, here's a question. We talked about those that have sort of the past 20 years, the new group of scientists. As you look back over the past 20 years, what do you think we've done right? What we've done that's been helpful? And what could we have done better as a group? So Doyle, why don't we start on your end?
Well, one of the things that did right was bringing the community together. So we've been able to benefit from having the conversations, explore, and being challenged. I mean, I remember sitting at a couple meetings before, we're in the material science space, and we adamantly believe that materials design is the key for U.S. economic growth. And then Dr. Rocco would challenge me and said, not just materials, but also systems. And he would be very clear about that. And so not only bringing the new ideas, but also being challenged. One of the things we benefited also from is understanding the liability piece from a business standpoint. And so being able to connect to different communities around that, not just the science, not just the testing, but also there's an insurance risk piece to this as well. And then working with, one of the benefits for us came out of that, some nano nav pal and some nanogrid, some other things have been done through the Army Corps of Engineers. That has been beneficial, but really building this community to have the conversations, to explore, to understand what works, what doesn't, or what might work or what might not.
Reggie?
So
Go next.
I think one of the things in terms of what we could have done better would have been more along the lines of the phrase of nano is for all. And what I mean by that is from an inclusivity standpoint. And when we look at where we've come from, and we all seen what's been happening over the years, especially with all the inclusivity aspects of it, you know, having engagement with all communities up front earlier probably would have done better in terms of the communication and getting the message out. Because I do know, like, you know, coming from a Black population, you know, one of the things I always hear from my parents and from other folks, growing up, it was always like, well, are you sure that's safe for us? Are you sure that's right for us? And so, and what they meant by that was, is this designed for certain people or is it designed for everyone? And even today, I still get that kind of question from my mom, because she's in her 70s and she's always still asking to make sure that I'm doing the right thing. And I appreciate that, but I always try to educate her, saying, Mom, we are working towards more inclusive aspects of these things. But again, that's still something in the back of minds. And so I think if we potentially had started earlier with, this is for all, I think maybe we could have developed things faster in other aspects.
So I think 20 years ago, when you were talking about interdisciplinary or transdisciplinary, or however you want to frame it, that was a computer scientist who had 1 hour meeting a week with a computer engineer. Like, they were stretching their boundaries and reaching out. I think nanotechnology has done a great job, and this group of people and the effort that we're talking about has done an amazing job of making interdisciplinary and transdisciplinary much, much bigger. So I'm trained as a historian and a social scientist, and I spend more time working with engineers than I do with historians and scientists. And for me, that's really exciting. And I think that has made this community so much more robust, able to respond, to engage with societal change and political change much, much better. And I think if there's one thing we haven't done quite as well, I don't know how that interdisciplinary nature has trickled down. I still think many of our programs, especially at the underground level, are very siloed, very focused on single disciplines. Our graduate students start to make those connections. They start to do the more bigger stuff. And I think we could probably do a lot more at the undergrad level to prepare students for the interdisciplinary world we live in.
Right, excellent answers. Let's now talk about regulation. And coming from a regulatory agency, it's a very interesting question. Regulation and innovation are often presented as opposing forces, but the NNI was founded with the goal of integrating regulatory science into nanoscale innovation. So the question is, how can the work of regulatory agencies accelerate and advance innovation in academia, industry, and the basic science agencies? So why don't we start with you, Reggie?
So we always talk about communication, wanting to not preventing all the blurred lines and everything else, like just communicate. And I think that's one of the things that with regulatory agencies is being able to effectively communicate what's coming down the pipeline earlier it would allow those of us that are scientists who are more upstream to be thinking about, oh, well, that's something that we should be considering as we continue to develop these ideas of ours, because a lot of us in the labs are just generating ideas. We're generating ideas. We're trying to help educate the students. We're mentoring these undergraduates and graduates and postdocs. And our focus is on helping them become the independent researchers that we want them to become, because they are our next generation. So we want to champion them for that next level. But if we don't know, hey, there's a certain policy coming down the pipeline, or there's this new policy that's being discussed, well, we don't know it, then how can we communicate that to those that are behind us, that are following in our footsteps? And I think that's something that, as we continue to talk about regulations and trying to make things better for all, it starts with all of us coming to the table and saying, hey, what do we need to do to work together?
I would just build on that. Great answer, but the one thing that we discovered is working with, is realizing, and that's a powerful word, is that we work with the agencies and not realize that they're against us. We all want the same thing. We all want safe materials. We all want the safe products to come to market. And once we realize that it's not us versus them, that was a big breakthrough and a barrier to overcome. Being able to understand those regulations and why they're being created. And a lot of times, if you share and you bring your ideas to the table, you can help actually mold those. There's opportunities when you work with them for them to have a better understanding as well. So working with the EPA, we've been fortunate to work with people like Lynn Bergeson, who has her own agency, but really understands the EPA as far as the materials development. That's been valuable for us, but then also with the other projects. So you get the different agencies involved. And then I'm going to bring Chuck's name up again, because he used to always talk about, well, I'm from the government and I'm here to help. And we always would get a big laugh about that. But at the same time, even though he wasn't a regulatory agency, we were able to tap into them and understand and utilize their resources and their guidance on moving forward. But again, I'll come right back to the word with. If we work with, we all move forward and learn in the process.
So I run a program called Science Outside the Lab, where I bring graduate students, scientists, and engineers and faculty to DC, and I embed them in policy conversations for a week or two. And a lot of those students will come with the idea of, if there were only just a handful of PhD scientists in Washington, DC, imagine how much better it would work. And of course, they get here and they realize, oh my God. But they sit down with regulators, and the amazing thing that happens is they come in again thinking regulators aren't people with PhDs, don't realize the background they have. And in those discussions, in just an hour, they have developed a profound respect for what policymakers do. They begin to understand the incredible complexities that are involved. What they used to think was an easy job done badly, they realize is a terrifyingly difficult job done as well as could possibly be done, and they want to help. And I think more that we can do to foster those developments, just like you both have just said, I think it'd be a huge, huge step forward.
Thank you. Do we have a question
Yeah,
online?
I think
Quinn?
building on what you've been saying, especially with the comment of with the agencies, and yours, a really, really difficult job being done as best as possible. One of the questions from the audience is more explicitly, if we could address it, how do we plan for and avoid possible unforeseen outcomes when it comes to nanomaterials? What are the safety in place? How do we try our best to avoid any kind of unforeseen outcomes? Could we address that?
All right, Doyle, you want to start with?
Well, back to the word with again, and how many more minds are better than few. So tapping into our academic friends, but many times have different views and have different access that we have, working with the agencies, the environmental labs that we've worked with, and there's a lot of consultants out there as well. And so when we get more people in the room, in the conversation, and again, one of the benefits of the NNI is being able to harbor that and foster that. I think that would be key to moving forward and what we have found.
Yeah, I'll follow up on that and just emphasize, like Doyle said, if we come together sooner and we recognize having foresight and that, hey, there's a potential problem here. Let's sit down and let's come to the table and kind of say, how do we mitigate this potential problem should it rear its ugly head before it actually gets out of hand? Because once, once the bowling ball or the stone starts going down the hill, it's going to reach a point you can't stop it. And so if we can actually come together before we let that boulder get down that hill going too fast, I think that's going to be much better than saying, uh-oh, there's a problem here and we need to figure out how to stop it now because it's already getting out of hand.
So there's a really important nuance in the question asker just asked, which is the word unforeseen. That's very different than unforeseeable. Unforeseeable is something we can't necessarily deal with, but unforeseen is something we can see if we actually take the time and effort to do it. So the Center for Nanotechnology and Society that I was mentioning earlier, one of the big achievements of that center was to focus on developing this idea of anticipatory governance, which starts with the basic premise that we can foresee a lot of these things if we take the time, the effort, and we get a really diverse group of people in the room to be thinking big picture. When you have people trained in very specific areas, it limits what you can and can't see. When you bring people together from a wide spectrum of backgrounds, disciplines, you can actually begin to flesh out much more fully what the possible futures are and hopefully lead us towards the futures we want to live in. And it's not just throw people in a room and chat. There's lots and lots of different techniques which are really powerful to get people to think in different ways and build new ideas and new knowledge that doesn't exist that would be really helpful in addressing this problem.
Great. Earlier, we talked about the research infrastructure. We have equipment, scientists, and perhaps principles of responsible development that we talk about in addressing nano and other emerging technologies. So one question we have, and you somewhat have covered this, how do we inject these principles into training of scientists and engineers, the new scientists? How do we continue these principles of and ensuring that we address the responsible development adequately?
All right, so I know I said earlier we need to do some changes in undergrad education. Forget I said that. I once had a professor that I worked closely with who was an engineer, but also did lots of social studies work. And he used to say, with the criticism, we don't teach scientists and engineers enough ethics. He would always say, scientists and engineers are always learning ethics. They learn it in the lab. They learn it from their advisors. They are learning what to do and what not to do through those examples. And I think the future of really, really hammering home an understanding of responsible development, you can teach some things in a classroom, great. But for most of us in the room, what we really do now is based on what we learned in the lab, working with our colleagues, working with our advisors. And that's, I think, where change needs to be focused.
Can I just say ditto? No, but seriously, in all honesty, yes, we can teach ethics in the lab. We can put students through an ethics course. We can put our graduate students through a responsible content and research type thing. That's fine and dandy. But here's my question. How many of them actually remember it? Right? How many of them, a lot of them will sit there and say, yeah, I had to sit through this course or I learned this in the classroom. That's great. But I didn't really appreciate it until I actually got out there working or actually doing something that involved some ethical decision they had to make or some action that could have some tremendous impact. They don't see it right there in the heat of the moment. All right. They only learn and learn the knowledge, but then to be able to use it, you have to put them in the situation. You have to allow them to grow into that situation and to develop themselves. So in terms of helping them become more responsible, it's by doing, to be honest. I mean, I can teach my students all the time, give them tons of scenarios or have them sit through all these trainings. But at the end of the day, I tell them, you're only going to understand this when you're put to the test. And you have to be willing to sit down and have these conversations when that happens to say, what should I do in this situation?
So I'm going to take two parts to this.
Mhm.
One is we get to practice that and take what you develop, and then we get to practice it in our own labs and in our own plants and manufacturing processes, and then putting them to the task and making those happen. But if we take a little bit, I'm going to take a little bit of divergent here because not only my parent, but my grandparent. And I'm starting to look now at seeing those smaller minds, and how do we expose and start planting these seeds early? And not only early, but often. And once the fact that nano is even part of our vocabulary now on a regular basis, much more so than it was, say, 20 years ago, is not, we're planting the seeds before they even become engineering students and in the university. And they have ideas and aspirations and thoughts that they can bring to life through the pathways of your courses and your programs, and then even take them further into the industry space. But one of the things, I know we celebrate Nano Day now with the NNI. And so how do we continue to build that? But as we build it responsibly, so that the nano is not just bad guys, but actually good guys as well in the comic book series that they'll be developing, or whatever approaches they take.
You have a question?
Yeah,
Oh.
I think this fits really nicely with what you just said, Doyle. I'm going to combine a couple of questions from the audience. They're asking, as we talk about nano EHS working to prevent environmental health and safety damage from nanotechnology, but how in the future can nanotechnology improve environmental health and safety outcomes? And taking it a step further, someone else asked, moving forward, could responsible development more forwardly inform research directions, especially in areas such as climate change, geoengineering, AI, et cetera? So instead of just looking at current research, how can we apply these ideas of responsible development, both positively for the environment and health, and also for our challenges that we have right now?
All right, so again, I meet with a lot of undergrads and graduate scientists and engineering students. They want to make the world a better place. That is why many of them chose to choose the fields that they're interested in. There was a study that was quite sad that came out about 10 years ago, where a social scientist interviewed students before, like their first few weeks of engineering, and then 2, 3, 4 years later. And what that study showed is that as they went through their undergraduate programs, the priority of doing something good for the world got smaller and smaller and smaller. There was something in their engineering education that was teaching them that their values that they came in with to the program were not important, and that they should be focused on much more specific, not worried about the big picture. That study is really sad to me, but I don't think it's necessarily predictive of what our future is. I do think the students that arrive wanting to be scientists and engineers, by and large, want to make the world a better place through nanotechnology and other approaches. And we need to enable that. We need to give them the support they need to continue those dreams and to find ways to actualize them, rather than trying to convince them that their career path would be better served, or they'd make more money if they went in a certain direction that may not be where their heart was at when they started down that path.
Sounds like we're talking about nano for good, which is, and so the keynote this morning, 1 trillion materials in a year, that's a lot of new materials, but how many of those materials are focused on good? How many, I would expect almost, well, all of them. And so one of the things that comes to mind, and we've talked about this in some of the different associations we're part of with, we're a member of one of the manufacturing institutes, NextFlex, which talks about the additive approaches to manufacturing. Well, then we see the keynote this morning about the different printed technologies. Are all these technologies going to have to be in multi-billion-dollar fabs, or can they be in smaller startup communities and smaller startup ideas? And so when we start thinking about that, how many new approaches? And so, I think I'm playing off of what you said, Jamie, in that the ideas that you bring or you come up with while you're in school, where can I go to do those? Maybe you can do those on your own or with a smaller business. And so the idea of distributed education, but also distributed manufacturing, how can that facilitate? And I think the nano can do that. But along with that, we're going to have to do that maybe one of the challenges is the regulations and the oversight, and making sure that it's responsible, and not from a top-down responsible, but making sure we're facilitate the responsible from the bottom up. And that may be one of the challenges we have to do. How do we build that in from the ground up? people don't want to make bad materials, don't want to make things that are bad, but if they can build them in and design them in from the beginning, that could be one of the challenges for all of us as we go forward.
So the American Institute for Chemical Engineers, which I'm part of, has a campaign called Doing a World of Good. And that's the theme. And I challenged my students this past semester on that theme and saying, you know, how are you as a rising chemical engineer looking to do a world of good? Because I wanted them to get off the whole bandwagon of, I'm in this major to get money. Make as much money as possible in this major. I wanted to get off that, say, no, you're becoming socially responsible as chemical engineers too. So what are you doing there? And I got a lot of good responses. And I remember one response that really turned my heart, because the person basically said, I want to take what I come out of here as a chemical engineer and the research that I do, because this person's going to go into grad school, and I want to show society how we can be environmentally responsible as chemical engineers. And what the person meant was they didn't want to just do research that was going to be the next Nobel Prize type research. They want to do research that actually helps society and actually help society recognize what good we are as engineers and scientists. And I think getting back to the question, I think the question was about how do we use responsible development to help us with our future research directions. That's one way of doing it. It's actually recognizing that our students already can think about those things if we sow the seeds. I mean, we're not asking them to come up and tell us right now, like, you know, how are you going to do a world of good? No, it's more of, if I sow these seeds in you, how will you be a responsible development citizen for the future? Because the future is yours. And I think all of our students recognize that. They know the future is theirs. And many of them are starting to become and understand that they have to take some responsibility in that they can't just rely on their teachers and those that come before them to lay that foundation. No, a lot of them want to get involved with helping to lay that foundation for the next step right now.
All right, excellent question. Great answers. You've touched on this, but I want to ask this question in a little bit different scenario. In Nano EHS, we initially said that we would look at the potential risks across the life cycle, from the production of a nanomaterial to its disposal and use. And ultimately, we want to commercialize these products. So can you talk about you preparing the next generation of students, and these principles, but across the life cycle and commercialization, with that in mind and with that goal of being able to safely commercialize these products? So, anyone want to tackle that?
Now, Trey, this is a loaded question, because one of the people we engaged with early on to ask about this with the whole product life cycle thing is somebody by the name of Trey Thomas. And so there's a lot of wealth of information out there, and working with him in his office. And so testing the product life cycle, testing the end of life, what happens after your product is disposed, it ends up in a landfill, what is the leaching back into the environment? There are so many things we have to think about, which is why it's great we have good minds that come to this or come to the table, but also into the community. But Trey, maybe you can expand on that a little bit, because I know that there was a lot of questions we would ask you. How do we test this? Where do we test this? What types of things do we pull in? We have to consider when we're developing a new product.
Putting me on the spot.
I am.
Well, that's what we're here to the panel, but I think why we have the panel. So I'll defer to your wisdom. How about that? Anyone else want to tackle that? Okay. No, we can move on to the next question. And we touched on this too, one of the strengths of nanotechnology, and it has been an extraordinary experience, I know, for me and for all of us, how we've engaged different communities, industry, academia, and so forth. A number of our stakeholders, the environmental health and safety community, Can you talk about, and also not only engaging these communities, but in the information that we collect and communicating with our stakeholders. So can you talk about the cross-disciplinary nature of Nano, the perspectives and ideas in your own organizations and just what that experience has been? Again, you've already touched on, but to go a little bit more in depth about this whole collaborative effort and the stakeholder engagement from your unique perspectives.
Well, one of the early products, or when we started getting into the carbon nanotubes, and a little bit of history there, we first got into the carbon nanotubes because they have semiconducting properties, and being in the semiconductor industry, we're looking at a product called NRAM, nanotube random access memory. In the process of developing that, we realized that there were some, in working with the Department of Defense, they needed a fully combustible temperature sensor. Well, you can't do that with metal. So we started using carbon nanotubes in sensing programs. Then we started realizing that they can be used in environmental sensing. There's different ways we can use those nanoparticles to do that. We worked closely with the environmental lab at the United States Army Corps of Engineers and found out that there are some people that are really passionate about this stuff. Mark Chappell and one, you start talking about soil. I had no idea there are so many different types of soil and where they are on the planet and what the different properties they have and how different products can be either eaten up by the soil or impacted by soil. So that was just one area that we found. But then working through them and their broad network, we started developing some other tools with them. And so we used our products and their tools. They came up with a thing called NanoGrid, where you can assess the potential liability. So that's one of the big things for us is the liability of a possible product and being able to test based on properties. And the knowledge and the passion and excitement that the people have about these different areas are way beyond anything I could comprehend. So when you tap into these different areas and these different pieces of the overall life cycle of a product and realizing that the people involved, and again, the people involved, every one of them along the steps, all care about the end result, which is doing good. But the value that each of them bring and setting up systems and tools that are be shared. And these things are shared and developed to be shared for common good across the planet, at least, and especially across the nation, is impressive. And so being able to have access to that and being plugged into that and then being able to benefit from that has been actually an impressive experience.
Yeah, I mean, from an academic side of things, we have multiple platforms in which the cross-disciplinary nature comes together and we can talk, especially with industry and folks like that. And, for different conferences, for example, I'm part of one of the Gordon Research Conferences, which is on environmental nanotechnology. And, having all the different minds come together during those 5-6 days there is great because we have different topics that come up and we all can talk about them in an open forum, whether it be like new cutting edge research or whether it be policy. I mean, sometimes there is policy that we have to talk about and how does that impact what happens next, especially going forward with the life cycle aspects of it from end of life back to saying, okay, how do you reuse this? Could we reuse it for a different purpose? So yeah.
Jamie?
Yeah, so when I started doing this kind of work and interdisciplinary engagement, I was always told that jargon was the major barrier. And once you got rid of your jargon, you'd be able to talk to each other just fine. I think that is hugely misleading. I actually think the major difference is different disciplines have different values, different goals, different approaches. And if you don't understand the other disciplines' values, goals, and approaches, you're not going to get very far in your interdisciplinary communications. There are a variety of ways to break down that barrier. I personally think the most important technique is called alcohol. I'm actually serious about that. I'm not saying lots of alcohol, but just enough alcohol to make people relax and want to get to know each other as a person and not just as this foreign discipline. I have always said, and someday I'll write the article, that the NSF will truly be interested in interdisciplinary when it allows its funding to be spent on alcohol. But there's another thing, and I want to look forward now. There's interdisciplinary, there's us talking to each other in this room, but there's also the relationship that we have with the general public. And there's an expert lay divide. And in a similar way, jargon, getting rid of jargon doesn't solve that divide either. Again, it's coming together and understanding our values, our problems, our goals. The way that we define goals and problems in this room is very different than somebody who is worried about whether their drinking water is safe to drink or not. And I think one of the major things we can do going forward that will help not just this room, but the country as a whole, is finding ways to allow those conversations to happen so that the problems that people in our communities have, we often have many tools or approaches that could actually very much help to address some of these problems, or creating those tools would be very quick and easy for us to do, and us being engaged to those conversations and responsive to those concerns that originate outside of the academia would be a great step forward, I think, in allowing us to pursue responsible development.
All right, thanks, Jamie. And we just have a little over 5 minutes left. So you touched on, I think, one of the final questions is, what new challenges in the responsible development of nanotechnology do we face? And what new tools do we have to meet these challenges? So Jamie, you've kind of touched on that, but is there more that you want to say? And then we can go Reggie and then
Give me
Doyle.
a second.
Okay. All right.
Sorry, can you repeat the question one more time?
So what new challenges do we face in responsible development of nanotechnology? We've hopefully done a pretty good job over the past 20 years, but are there new challenges that we need to focus on, and specifically in nano EHS?
There is, and I'm trying to figure out the best way to put it, but it's when we all know that when we get into something, we get used to it, right? And we say it becomes just norm. And then we allow that norm to just become the status quo. And ultimately that status quo will begin to cause us to get really just numb to any kind of like potential hazards that can come about. And so we've seen this in history. We've allowed things to happen, and then we all go, oh, everything's fine, until all of a sudden it's not fine. And then we're scrambling to try to figure out what do we do? And I think that from a responsible development standpoint, and us moving forward with nanotechnology, I think we all need to make sure that we don't allow ourselves to become callous to the idea that nothing can go wrong, because we've gotten rid of all the potential hazards. Because as from an engineering standpoint, there's nothing perfectly safe. All right, there is no such thing as ever being perfectly safe. There is always an inherent danger somewhere, and whether it rears its ugly head right in front of us or it takes time to come about, that's something we need to keep in mind. Because if we don't, we may end up opening Pandora's box by mistake, and something drastic happens that we aren't expecting, and we need to be mindful of that.
Doyle, new challenges, and do we have the tools to meet them?
So I'm going to build on that. So I agree with everything you said. And so maybe rephrasing it or just adjusting it a little bit, the word speed comes to mind. The speed in which we're going to be inventing new materials is accelerating. And the problems we're going to have with those, or maybe not foresee, is going to also accelerate. So the presentation this morning, they talked about one of the big challenges going forward for AI. Well, if we apply AI to new material development, what kind of data is out there? And when we have speed like this and we need more data, and now everything's proprietary and we want to protect our data, how much data is being protected that could be beneficial for other people to know as we develop these materials? And what is the trust of sharing such data to not have, I'm struggling a little bit here, but if we don't share the data to know what those next challenges are as the speed increases, I think there's some potential hazards, as you said. It's not a hazard until it is. And so what do we do with that? And how do we protect from a intellectual property standpoint, but also share at the same time so we can actually overcome and foresee these?
So sharing.
Yes.
Data nanoinformatics, we have is important. Absolutely. Jamie, do you want to touch on this question?
Yeah, I'll just say, I mean, I want to come back to this idea of tools. I mentioned earlier the importance of not just defining problems in this room, but finding out what local communities see as problems and figuring out if we can engage with them and find solutions to the problems that they're worried about. I think we have seen a degradation in the authority of science over the last 20, 30 years. I don't think nano is I don't think nano is sort of a reason for that or outside of that. I think it's wrapped up with many, many other things. And I think finding ways to make that communication with a broader array of stakeholders, which it should include the general public, is really, really important. There are really important and useful ways to have those conversations. They can be done on science museum floors, and those conversations have happened many times, and there's great techniques for doing that. There are ways of bringing representative samples of the public together to discuss their concerns that have actually been used by a number of agencies in the federal government to help direct possible ways forward. And I think strengthening those kinds of approaches and doing more things like that within Nano and well beyond Nano would be wonderful.
All right, well, we have just a minute left. When do we have a last minute question? Otherwise, why don't we end this? It hasn't been enough time, but you all have done such a great job in answering these very tough questions and giving us a lot to think about. Let's thank our panelists, everyone. And thank you, those online, for your questions.